moisture and cloud formation. As we shift from the dynamics of atmospheric winds into the realm of moisture, we enter one of the most fascinating aspects of Earth systems, the water cycle. Water is unique in that it exists naturally in all three states, solid, liquid, and gas, at the temperatures commonly found on Earth. This versatility is central to weather, climate, and life itself. Moisture in the atmosphere exists primarily as water vapor. The amount of water vapor air can hold depends on its temperature. Warm air can hold more, cold air less. This relationship is key to understanding why condensation, clouds, and precipitation form when warm moist air rises and cools. When air cools to its dew point temperature, the water vapor begins to condense into tiny droplets or ice crystals, forming clouds. The type of cloud depends on altitude, temperature, and the nature of the air movement. Cumulus clouds are those fluffy, cotton-like forms we often see on fair days. Stratus clouds are layered and cover the sky like a blanket, while cirrus clouds are high, wispy, and made of ice crystals. The water cycle. The hydrologic cycle describes how water circulates continuously between the atmosphere, oceans, land, and living organisms. The main processes are: evaporation, water changes from liquid to vapor. Condensation, vapor cools and becomes liquid droplets. Precipitation, water falls to earth as rain, snow, sleet, or hail. Infiltration and runoff, water moves into the ground or flows over it. Transpiration, plants release water vapor from their leaves. This cycle is powered by solar energy and regulated by winds, weather patterns, and the physical characteristics of the landscape. It is a closed system in terms of total water, but the distribution of water between oceans, atmosphere, and land is constantly changing. Precipitation types. Precipitation occurs in several forms. Rain, liquid droplets falling through relatively warm air. Snow, ice crystals that form in cold clouds and remain frozen until they reach the ground. Sleet, raindrops that freeze before hitting the ground. Hail, balls or lumps of ice that form within strong thunderstorms. Each type of precipitation is tied to specific atmospheric conditions and can tell us a lot about the weather systems at play. Air masses and fronts. An air mass is a large body of air with relatively uniform temperature and humidity. These air masses form oversource regions, areas with consistent surface conditions, like oceans or deserts. When different air masses meet, the boundary between them is called a front. Fronts are classified as cold fronts. Cold air pushes under warm air, often causing storms. Warm fronts, warm air slides over cold air, producing steady precipitation. Stationary fronts, neither air mass advances, leading to prolonged weather patterns. Occluded fronts, one front overtakes another, common in mid-latitude cyclones. Storm systems. Earth's weather is often dominated by organized storm systems, ranging from local thunderstorms to massive tropical cyclones. Thunderstorms are intense but short-lived storms characterized by lightning, thunder, heavy rain, and sometimes hail. They form in unstable air where warm, moist air rises rapidly. Tornadoes are violently rotating columns of air extending from a thunderstorm to the ground. They are among the most destructive weather events but are usually small in scale and short in duration. Tropical cyclones, known as hurricanes, typhoons, or simply cyclones depending on the region, are massive, low-pressure systems fueled by warm ocean waters. They can bring catastrophic winds, storm surges, and flooding. Oceans and currents. The oceans cover over 70% of Earth's surface and are integral to climate regulation. Ocean currents move vast amounts of heat from the equator toward the poles and cold water toward the equator. The Gulf Stream, for example, warms northwestern Europe, while the California Current brings cool water to the U.S. West Coast. Currents are driven by wind patterns, Earth's rotation, the Coriolis effect, and differences in water temperature and salinity. These currents also influence marine ecosystems, weather patterns, and even fisheries. Freshwater systems. Freshwater, though vital for human and ecological survival, represents only a tiny fraction of Earth's total water. It exists in rivers, lakes, wetlands, and underground aquifers. The distribution of freshwater is uneven, with some regions facing scarcity while others experience abundance. This unevenness is at the heart of many environmental management and political challenges. Climate zones of the world. Climate is the long-term pattern of weather in a region. Factors influencing climate include latitude, altitude, ocean currents, and proximity to large water bodies. The major climate zones include tropical, warm year-round, with high rainfall in rainforest or distinct wet/dry seasons in savannas. Dry, desert and semi-arid areas with limited precipitation. Temperate, moderate temperatures and seasonal changes. Polar, very cold with ice and tundra landscapes. Highland, varies with elevation, often cooler and wetter than surrounding lowlands. Human impact on climate. Human activities, especially the burning of fossil fuels, deforestation, and industrial processes, are altering the atmosphere's composition. The increase in greenhouse gases, such as carbon dioxide and methane, traps more heat, leading to global warming. This warming affects sea levels, weather patterns, biodiversity, and human livelihoods. Global climate change. Climate change is not a distant threat, it is happening now. Glaciers are retreating, Arctic sea ice is shrinking, and extreme weather events are becoming more frequent. Scientists project that without significant reductions in greenhouse gas emissions, these trends will accelerate, with profound consequences for ecosystems, agriculture, water resources, and human health. Adaptation measures, like building resilient infrastructure, conserving water, and protecting natural ecosystems, are essential. But equally important is mitigation, which means addressing the root causes by transitioning to renewable energy, improving energy efficiency, and preserving forests. Conclusion. The study of physical geography reveals just how interconnected Earth systems are. From the motion of the atmosphere to the flow of the oceans, from the growth of a single plant to the movement of entire weather systems, every part of the planet is linked. Our challenge as geographers, scientists, and citizens is to understand these systems well enough to live sustainably within them.